Determine the values of x for which the geometric series converges. Then find the sum of the series for these values of x in terms of x. We are given the sum from n equals 1 to infinity of the nth power of x plus 2. Recall an infinite geometric series always fits the form where the formula is a times r to the power of n, where r is the common ratio, and if the absolute value of r is less than 1, the series converges, and it converges to a, the first term, divided by the quantity 1 minus r. Notice for the given infinite geometric series, we have r equals the quantity x plus 2, which indicates to determine for which x values the geometric series converges, we need to solve the absolute value inequality, the absolute value of r, or in our case, the absolute value of the quantity x plus 2 less than 1. Recall to solve an absolute value inequality, we need to set up and solve two inequalities connected with the word and. We have x plus 2 is less than 1 and x plus 2 is greater than negative 1. Notice for the second inequality, we reverse the inequality and change the 1 to negative 1. And now we solve. Notice for both inequalities, we need to subtract 2 on both sides to isolate x. Simplifying on the left, we have x less than negative 1, and on the right, x greater than negative 3. Let's go ahead and graph this interval on the number line. Because of the inequality symbols, we know negative 3 and negative 1 are not in the solution. We make open points on negative 3 and negative 1. We're looking for the x values for which x is less than negative 1 and greater than negative 3, which are all the values between negative 3 and negative 1. We now know the series converges when x is on the open interval from negative 3 to negative 1. Using interval notation, we have open parenthesis negative 3 comma negative 1 close parenthesis. And now let's determine what the geometric series converges to, or what the infinite sum is, only when x is on this open interval. Recall the sum is equal to a, the first term, divided by the quantity 1 minus r. We already know r is equal to x plus 2. Notice n starts with the value of 1, which indicates a sub 1, the first term, is the first power of x plus 2, or just x plus 2. And therefore, the infinite sum is equal to a sub 1, which is x plus 2, divided by the difference of 1 and r, which is 1 and the quantity x plus 2. Let's go ahead and simplify. We have the quantity x plus 2 divided by 1 minus x minus 2. Let's write the infinite sum as the quantity x plus 2 divided by the quantity negative x minus 1. So we'll say on this interval, the infinite sum is equal to the quantity x plus 2 divided by the quantity negative x minus 1. I hope you found this helpful.